Hey guys, we are here today with Module 5, Lesson 17, and with that, we're going to continue placing fractions on a number line, including fractions greater than 1. So last time we talked about how two things are really important in doing this. One, the ability to find the numerator for fractions greater than 1, especially those whole number fractions greater than 1. So we talked about multiplying the whole number times the denominator to find the numerator. And we also talked about how we can help ourselves by color coding the holes on our number line. That's not something you'll do forever, but it's a good way to get started. It's a good way to develop an understanding so that later on you don't need them. So I will do both of those things today, and we will practice again like we did last time. Let's take a look at the problem set. So on the problem set here, you see we're going on this first problem from 0 to 3. So you can see we have 3 holes within here. So the first thing I'm going to do is I'm just going to shade these in or use a marker and highlight the holes. So that's 1. Here's the second hole. And here's the third hole. Okay, so we have 3 holes there, and as you can see, we're dividing each of the holes into 6. That what I just said is really important. Each of the holes gets divided into 6, not the whole line. So this orange part gets divided into 6 parts, the red part gets divided into 6 parts, and the pink part gets divided into 6 parts. So we can do that by dividing into thirds first, and then taking each third and dividing it in half for each of our sections. Okay, so now I've divided it into 6, and I need to figure out where all of the 6 go. So 0, 6 goes here. 6, 6 goes here. I'm going to cross them out as I do them. Right? 6, 6 is 1. I know that because we've talked about it a lot, but also because 1, the whole number, times the denominator 6 equals 6, the numerator. 3, 6, I noticed that the numerator is smaller than the denominator, so that fraction is less than 1. So 0, 6, 1, 6, 2, 6, that goes right here. 3, 6. 9, 6, okay, well that's 6, 6. 7, 8, 9, that goes right there. 9, 6. And then my last one is 12, 6, okay. Where could that go? Well, I guess I could count on from here. 9, 10, 11, 12. 12, 6. Another way I could have seen that is could have said, oh, I know that 2 times 6 is 12, so it must go there. And we can do that. The whole number times the denominator equals the numerator. So we could have figured it out that way as well. I think one of the best ways to do this when you get a problem like this is to find out what the whole numbers are. And then, so if you knew that this was 6 and that was 12, you'd obviously the 9 would have to fall in between those. Same with this. This is 0 and this is 6 in terms of numerators. 0, 6 and 6, 6. You know that 3, 6 has to come between those two things. So it narrows down your options. Let's take a look at the next one, which is working in fourths. Again, we have 3 holes here. So we'll shade those in or label them with different colors, mark them with different colors rather. We substitute out our red for our green here. And again, I'm going to mark each of them in fourths. When I mark fourths, I make a halfway mark, and then I take each of the 2 halves I created and cut those in half again. So I have all my markings on there now, ready to go. I'm going to look for an easy one first, 4 fourths. Oh, that goes here, 4 fourths. Notice we didn't start at 0 this time, we started at 1. And then I'm going to look for other multiples of 4, meaning 4 times some number equals the numerator. So like I know 4 times 2 equals 8. So this one has to go here. 4 times 2 is 8 over 4. Now look, I have 4 fourths and 8 fourths. Well, 6 fourths has to come between those two numbers. So I've narrowed my options down to that 6 fourths has to go in this pink section somewhere. So 4 fourths, 5 fourths, 6, oh, it has to go right there. 6 fourths. 12 fourths. Ooh, I noticed I multiply that 3 and that 4 together, I get 12. So that must be equal to 3 or equivalent to 3. 12 fourths. In this last one, I also noticed if I multiply 4 times 4, the whole number times the denominator, I get a numerator of 16. 16 fourths. So I got my whole number. Whole number of times my denominator equaled my numerator there in that case as well. Let's do one more just like this. This time I have 1, 2, 3, 4. I have 4 whole numbers starting at 2 and ending at 6. So 2 to 3 is one color. 3 to 4 is another color. 4 to 5 is a third color. And lastly, 5 to 6 is a fourth color. And again, doing that just helps you see that there are 4 holes on this line, and each of the holes has to be split into thirds. And you might say, well, how do you know it has to be split into thirds, Mr. Brown? And the reason for that is that the denominator is 3 in each of these. So that just tells us that each section or each hole on our number line is being split into 3 sections. So I'm doing that now. And now I have the job of going ahead and finding out where all of these things go. I'm going to start with 6 thirds because I know that 2 times 3 is 6. So that has to go here. Again, my whole number times my denominator equal the numerator of 6. I know if I do 3 times 3, I get 9. So this must 9 thirds equals 3. I also am looking here, I notice 11, 14, and 18 as numerators. None of those numbers fall between 6 and 9. So nothing else is going to go in this section. I've ruled that out a little bit. But I do notice that 11 is close to 9. So I could count on perhaps and say 9 thirds, 10 thirds, 11 thirds right there. I could then count down and say 12 thirds, 13 thirds, and 14 thirds. That works. In my last one, I think I would say, ooh, this looks like a multiplication fact, I know. 6 holes times 3 is 18. So 18 thirds is equal to 6 holes. And we filled that entire part out now. So it's a good strategy to go through, look at your holes and multiply them by 3 and see if they equal any of the numerators that you have. And if they do, you've already identified some fractions. Once you've identified those whole numbers, those whole number fractions, then you can go ahead and find the ones that fall in between the holes on your number line. Let's take a look at some word problems that are associated with this. So for a measurement project in math class, students measure the lengths of their pinky fingers. Alex is measured 2 inches long. Jeremiah's pinky fingers was 7/4 inches long. Whose finger was longer? Draw a number line to help you prove your answer. Okay, so I'm gonna draw a number line. I'm gonna go from 0 to 1 to 2 to 3. Those are like reasonable lengths of pinky fingers, you know, not 0 necessarily, but 1, 2, and 3 for elementary school students, I suppose. And I'm working in fourths of an inch. So I need to split each section into fourths. So that's one hole that got split into fourths. This is another hole that got split into fourths. And finally, a third hole that got split into fourths. And now I'm going to find 2 inches is right there, and that's 8/4. So 2 times 4 is 8. So this is equals Alex. So now I need to figure like 7/4 of an inch long would be less than, it would be further to the left of. So 7/4, which is Jeremiah's, is right to the left of or just less than Alex's. So I would say that Alex has a longer pinky finger. His is 8/4 inches. Wow. I'm not gonna spell out Jeremiah, but Jay's is 7/4 inches. So 7/4 of an inch is just less than 2 whole inches. It's 1 3/4 of an inch. But 1 3/4 is another way to say that. Marcy ran 4 kilometers after school. She stopped to tie her shoelace at 7/5 kilometers. Then she stopped to switch songs in her iPod at 12/5 kilometers. Draw a number line showing Marcy's run. Include her starting and finishing points and the 2 places where she stopped. So her starting point was 0. She hadn't run any at all. So 0, and we're measuring in fifths of a mile, so 0/5. And her ending point was at, or kilometers rather, was at 4 kilometers. And we're measuring in fifths. So 4 times my denominator of 5 is 20. So I have 20/5 is the same as 4 kilometers in this case. And in between those, I have 1 kilometer and 2 kilometers. So first kilometer, second kilometer. Oh, I forgot a kilometer here. First kilometer, second kilometer, third kilometer, and fourth kilometer. And each section is going to be split into fifths. I can color code those just like I did earlier. That's a good habit to get into. Especially, like I said in the beginning, to learn these things. Like, when you're in high school, you don't necessarily have to be color coding the holes on your number lines that involve fractions. But when you just learn something, it's important to use the tools that help you understand them better. So 1, 2, 3, 4. I'm dividing each line, each hole into 5 parts by drawing 4 lines. And then I've done 2 of the things they asked. They said the starting point and the stopping point. I just marked those in reverse order, but the only other thing I need to do now is include the spot where she tied her shoe and the spot where she switched songs in her iPod. So 7/5. Well, one way to do it is say 0/5, 1/5, 2/5. I could do that. Or I could say, I know that 1 is 5/5. Because I know that 1 is this when the numerator and the denominator are the same. And then you could go ahead and say, I can count up from there, 2 more. 5/5, 6/5, 7/5. 7/5. That's shoe. And then 12/5. Okay, well, 2 times the denominator of 5. Oops. 2 times the denominator of 5 is 10/5. Okay, so then let's move on from there. 11, 12. It's right there. 12/5. And this is iPod. And that's how you go about finding points on a number line greater than 1. So yesterday we learned mostly about the whole number portions on the number line. Today we still did some of that, but we also learned about finding those points on a number line greater than 1 that are not whole number fractions. You guys are working very hard. I know this is tricky and new information, and I hope that the tools that we are learning in class are helping you develop a better understanding. As I always say, please keep asking questions if you have them.